to the Raw Data tab. In this video, we will walk you through how to load your data, apply filters, find events, and save these events for downstream analysis. So let's get to it. First of all, I want to point out that as we saw at the beginning, in the top menu, we have options such as load time series, load events, new filter, new analysis tabs, etc., etc. All of these submenus correspond to the different plugins that Poriscope has. However, all of the analysis tabs, as mentioned, have control panels, and these control panels have been designed in a sequential way as to make the analysis process easier and intuitive. So even though there's technically two ways you can load your data or instantiate different plugins, I would say stick with the one that we are going to in this video and using the control panel. Use the control panel directly instead of going to the top menu, and the only circumstance in which you have to go to the top menu is when you are instantiating an analysis tab for the first time. So we have opened the application, we have clicked in raw data, and then we want to load a time series. So you would select a reader, but as I said, we are going to do it in the control panel because the control panel is a step-by-step process. So here we are going to load our data. We want a reader, so we're going to add a reader. We click on the add symbol, and we're going to select the reader that matches the extension the file we are working in. So I have a log file. I'm going to select this Chimera right here, and then I can switch the name. The name corresponds to the name of the reader you're using, plus the number of the instance of the reader. Since it's my first one, it's going to be 0, Chimera reader 0, and then I'm going to actually select the time series. I'm going to click open it, and then we are going to look at the login panel. As I mentioned at the beginning, login panel is super important for checking your step-by-step. You can see your analysis, like each step of the analysis. So now we're in raw data as a step containing milestones. So here, for instance, we have reader, filter, event finder, writer. Super straightforward. They are even divided in different columns as steps that you have to complete. Though the filter is technically option, but is easier if you think about them as different milestones you're completing. So I have completed the reader milestone. So now what I'm going to do is I'm going to check the login panel, and I'm going to see, okay, this is the name of the file of my reader. And then I have 4 channels of data. This is the sample rate, and then these are the seconds of data per channel. Really important because, I haven't even started my analysis, and I already know that channel 2 has 0 seconds of data. So if I was to try and find events in that channel, it would be unsuccessful. And maybe if I hadn't checked my login panel, I would try and find events in channel 2 and then be confused and worried about the fact that I'm not finding any. But it actually makes complete sense because there's no data to find events in. So just one of the many nice advantages of checking constantly the login panel as you complete your analysis steps. So let's actually, now that we have loaded our time series, let's actually plot the traces, plot some seconds of data. So we're going to see, let's say we'll do 5 to 10. So we're going to plot 5 seconds. Just for the sake of showing it, let's actually select channel 2. Like we cannot just say we want to visualize 5 seconds. We have to choose the channel of which we want to see this time. So we are gonna update it for channel 2, and surprise, surprise, there's nothing. But we already knew this, so it's fine. If we hadn't checked the login panel, we might be concerned about it. But because we did, we know this is completely normal. This is the expected result. So actually now let's plot something that has data. Channel 3 has 330.5 seconds of data. So let's see that trace. And here it is, channel 3 from 5 to 10. We can see farther on. If we click the arrows, 5 to 10 is 5 seconds. So whenever we click the arrows forward, we're going to go 5, 5, 5. If we go backwards, we're going to go same thing, 5 to the left. But of course, it's only positive ranges. You cannot keep going backwards if you already started at 0 to some other value. So this trace is a little bit more noisy than we would have liked. So let's apply a filter for that. Before doing that, we can also check the PSD. But yeah, let's add a filter. So there's 2 filters you can add in Poriscope. The first one is a bezel filter. That's actually the one I'm gonna be adding. So the bezel filter reduces high frequency noise, and you have parameters you have to fill. You have name, cutoff, sample rate, and pulse. We're gonna add that. But you could have also added a wavelet filter, and this wavelet filter actually comes pre-compiled for you in Poriscope, so you could have also done that. And what it does is that it preserves pulse shape while denoising. So this is another option, but we are doing the bezel filter. So we're gonna, actually before we select it, we're gonna update the trace again. And then we are gonna apply the filter and update it one more time. And way better, way less noisy. So now we can actually get our baseline stats. And if we're happy now, then we can proceed with the next milestone if you make, which is event finding. So detecting our translocation events. So we're gonna go here, we are event finder. As before, we click on add event finder. There is 2 event finders that Poriscope ships with. So the first one is, we have here the bounded blockage finder. This is not the one we're gonna use right now, but this is what this finder does, is that it adds the baseline constraints that will exclude sections of data where the baseline is outside the preset bounds you check. You establish, so here you have mean baseline, max baseline. So this is very useful, for instance, for excluding clock data segments. But we are gonna be using the classic blockage finder, which is a simple threshold-based detection that allows for a drifting baseline. We're gonna set the name, the meta reader, threshold, minimal duration, max duration, and mean separation. Very important, meta reader parameters, super important. So event finders, as many of the other objects that come from the plugins in Poriscope, are locked to other plugins. This is all metadata, but so basically the event finder has to be associated with a reader, has to be locked to a reader. Here I have only one reader selected, but you're able to have multiple readers at the same time, and you would have to make sure that if you want to find events for a specific one, you make sure that you're selecting the appropriate name. So then you do that, and then we have here classic blockage finder 0 and chimera reader 0. If I had here classic blockage finder 0, which is locked to class 2 chimera reader 0, but here I have chimera reader 1 selected, I will get an error and I wouldn't be able to find events, as I'm trying to find events in a reader that is not the actual file where that my finder is locked to, is associated with. So just something to keep in mind. That is a classic mistake, to have the wrong reader selected and be wondering why you cannot find events when it's just a mismatch in the different objects. So just really important to keep in mind. Additionally, you can have multiple event finders, multiple readers. If you're using the bounded blockage finder particularly, it's because you're setting bounds. Not all channels may have the same bounds, so it's really common you can have different blockage finders. So you have one reader and you have different blockage finders with different bounds, and then you just keep the same reader but have different finders and do find events according to each channel. Now that takes me to another point. You have to select the channel for which you want to find events. So for instance, if I select channel 2, because I love channel 2, it's really good for showing edge cases. So, and I click find events, channel 2 event finding incomplete, which is not surprise because again, channel 2 has no data. Now, what happens if I select channel 3? I click find events, and there it is. We see the progress bar, 4, 5, etc., etc. A really cool feature is that you can set time limits for your event finding, especially with, for instance, binary files. It can take a long time. So you can say, for instance, channel 3, I only wanted to look for events in the first 10 seconds. So then you do that, you click find events again, and it's going way faster than before because it's not going to 300 seconds now, but only 10. And in those 10 seconds, it found one event. So then, depending on that, you can adjust, augment the amount of time you're looking in, and so on. Now, also important, here I had the filter was still on. What happens if I remove the filter? I click find events, event finding, yes. Start over, yes. So now it's going kind of slower, which is really interesting. And this is because the filter is off now. And it's going through the signal to the unfiltered signal. So yeah, just something to consider. If you can also, the filter applies to all the channels you're selecting during event finding. I could also do that. I cancel this and I can click here, event finding incomplete, because I cancel it. I could do, well, actually let's do 10 for all of them. 0 to 0 is like the full time. So it's 0 to 0 is like saying 0 to whatever it goes. You could also, actually it's cool because you could do 5 to 0, which means do from second number 5 up to the end. But let's do just 5 to, let's just do the same for all of them. And then you click find events. Channel 2 is not doing anything because there's no data there. And then found one event for all of them. I'm not looking into a lot of data, just because it's quicker. I want to show it to you guys. Once you have your events, well, in this case, let's actually find one longer just so I can show you more. So here I have finished running 50 seconds of data in channel 3, and I have found 15 events. So now what I'm going to do is I'm going to plot them. So let's say I want to plot 8 events. Here they are. It is recommended to plot up to 16 numbers. Once you go above that, it's difficult to see depending on how long the titles are. They could overlap. So better to keep it at 16, but since we have 15 here, we can plot them all. So there it is, our 15 events. Remember, we start at 0, so it's up to 14. And don't get worried, don't be like, where is event 15? No, it starts at 0, so here it is. And if we are happy with our results, we can proceed to milestone number 4. Again, we have found events and we have constantly been looking at our login panel. So that's how we knew we found one event here in channel 1, channel 2 incomplete, channel 1, channel 3 incomplete, channel 3 15 events. I ran it twice, so that's why it's there twice. And we can proceed with writer. So instantiating a writer, we go to add writer and we're gonna select SQLite event writer. This is the only writer for events Poriscope has. We click OK, and then we're gonna choose the name. Same principle as for filters and for readers regarding the name, but you can change it. Same principle as for event finders. Your writer is logged to an event finder. As I mentioned in part 1, the objects are strongly depending on one another. They are really interconnected. So your writer depends on your finder depends on your reader. And we will see also how this affects when you are deleting them. So for instance, here, well, we only have one finder, so we're gonna lock it to it. And then select output file. We are going to put it here. We're gonna say tutorial events. So that's the name of my SQLite file. We're gonna save it. We're gonna add experiment name. This is really interesting because you can add multiple experiments into the same into the same file, which is really practical, especially if they are interconnected. We are actually gonna, I like seeing this better in the event analysis, so I'll walk you guys through that in the event analysis video, which is the next one, but we'll call it tutorial experiment. And then the voltage, the membrane thickness, and the conductivity. So we click OK once we're happy with that, and then we have our writer. So writing is really cool. Same thing, channels are really important. Always make sure to verify that you, for instance, which channel you are seeing the trace for, which channel you are finding events in, which channel you are plotting. Here I was plotting channel 3. Same thing for writing, which channels do you want to write. So really important here is, for instance, the last time I ran the finder, it was on channel 3. I found 15 events. What happens if I select channel 1, and channel 1 has events, we know it. What happens if I select it and then I click commit events? Wrote 1 events, rejected events 0 in this case. But yeah, because we had previously ran the finder for channel 1, and the last time we ran it was with 1 second. What happens if we were to change this and then we do 0020 and then we run it again in channel 1? Yes, event finding was already complete in channel 1. We know this, that's why we were able to write. So we ran it again. Okay, now we found 6 events. I want to commit those events. Wrote 5 out of 6 events. Why was that? Well, that was because we had already write 1 out of those 1 event previously, so now there's only 5 that were left to write. What happens if we actually don't do anything, we don't run the finder again, we just commit events? 0 out of 6, because all of these 6 events have already been written, so there's nothing being, it is not getting overwritten, so we're writing nothing. What happens if now I select all of the channels and I commit them? Okay, channel 1, row 0 of 6, we knew that makes sense. Channel 4 wrote 1 out of 1, channel 2 wrote 0 of 0 because there's nothing, and channel 3 wrote 15 out of 15. So that's perfect. As you see, even though we had run the event, the last time we ran the event finder, it was only for channel 3. The previous runs with the different channels were stored, so we don't have to rerun it every single time before we save them. What happens is it's gonna keep the last effective run that we did with the finder, and then if we wanna write it, it's gonna write that last effective run of finder we did. And if we wanna, if we keep writing the same and the same, it's not gonna get overwritten. So here I have efficiently written the 4 channels. You don't have to do this necessarily. For instance, maybe you only want to focus on channel 3, so you would have only written channel 3. You can decide how to go about it. And because this is the same writer, they are all being saved under the same experiment. So as we saw in the previous video, we have efficiently and effectively written the 4 channels into our database. What is really cool is that what's getting written is only the immediate data within, and it's only the data immediately within and immediately around the event, which means that it's ignoring all of the open port baseline that is in between all of these events where there is nothing. So that saves us a lot of space. And now if we check how that database looks like, well, we recommend if you want to check your database, you can use DB Browser for SQLite. It's a free, really good tool for checking them. So really important thing, you did not have to write your 4 channels. You could have just chosen to write 1 of them, 2 of them. It is your choice. Actually managing databases in Poriscope is really interesting. And once we get to metadata and to the next video, we will dive deeper into it. But for instance, so far, well, once you open your database in the DB browser, you can see we have 4 tables, channels, columns, events, and the SQLite sequence. If we actually want to browse the data, we go to channels. It's a tutorial experiment. Remember, we name it that. We have channel 1, 4, 2, 3. And then we can actually see the events. So remember, there were 6 events in channel 1. 1, 2, 3, 4, 5, 6 events there. Channel 4 had only 1 event. There is 0 events for channel 2, and then there should be 15 for channel 3, and there's 15 rows, so that's correct. So you can see your data here, and we'll see how this can be useful in the next video. But you can see also we have indeed saved all the events that we detected in all the 4 channels we chose to find events in. And since we chose to save all of these 4 channels, we are able to see them here. In the next video, now that we have saved our events, in the next video I will show you how to load them and how to fit them. You have now prepared your raw signal and actually saved detected events into a database. Real important note, your initial time series is intact. Nothing happened to it. You could reload it once again, apply completely different filters, completely different finders, and find a different number of events and then write them again. It's intact, nothing happened to it. This is a new file that has been created with your events, with the minimally required data to save your events and their metadata and important features you'd like to extract from them. So in the next video, I will show you how to load these events and fit them.